Are you one of those who believe the universe is infinite? A common belief, perhaps, but likely incorrect. Researchers have uncovered a surprisingly simple proof suggesting our universe possesses a boundary. This doesn't, however, imply a limit to creativity or exploration. What lies beyond that boundary? What is its nature? Prepare to explore a universe structured by numerous systems and defined boundaries. Natural science relies on straightforward observations and logical deductions. Mathematics and experimentation play supporting roles in unraveling the enigma of the universe's finitude. The discovery of this boundary required no complex calculations or computer simulations. The answer was readily apparent upon observation. Get ready for a journey into the cosmic depths. Our voyage begins at the edge of the Milky Way galaxy, our home. We observe that the Milky Way, a closed system, contains countless smaller systems within its confines. It moves independently through the universe. The small and large Magellanic Clouds, our nearest galactic neighbors, are situated 165,000 and 200,000 light-years away, respectively. Andromeda, the next major galaxy, lies a significant 2.537 million light-years distant. Noticeably, even these galaxies are systems with defined boundaries, maintaining their integrity as distinct entities. Galaxies comprise millions and billions of star systems, each with its own boundaries, leaving ample space between neighboring systems. The known universe, to date, likely contains over 500 billion galaxies, a staggering number. Over 500 billion galaxies, each a universe unto itself. At the heart of the Milky Way resides Sagittarius A, a supermassive black hole. These enigmatic phenomena interact powerfully with their surroundings, likely playing a crucial role in galactic formation. Black holes engage in a unique cosmic dance. They move, collide, and merge with other black holes, shaping the very fabric of the universe. Their influence extends far beyond their immediate vicinity, constantly reshaping the landscape of the cosmos. The boundary of the universe, then, is not simply a physical limit, but a complex interplay of forces and systems, each with its own defined parameters, creating a universe of breathtaking scale and intricate design. The boundary is not an ending, but a continuation of this intricate dance, a testament to the universe's boundless complexity. We're plunging into the Milky Way's outer spiral arm, home to our solar system, a universe within a universe. Our sun and its planets are mere specks in the cosmic expanse. Earth, Venus, Mars, and even distant exoplanets are tiny worlds within a far greater reality. While Earth teems with vibrant life, other planets might resemble frozen wastelands or microbial havens. Defining the precise boundaries of our world is a challenge, yet those boundaries exist. Earth's atmosphere, culminating in the thermosphere, merges with the Earth's magnetic field at a specific altitude. Other planets exhibit similar, though varying, boundaries. Mars, for example, lacks a substantial atmosphere, but its magnetic field still defines a limit. Venturing to the edge of our solar system, we reach the heliopause, the boundary where the solar wind's speed dramatically drops from nearly 1,000,000 kilometers per hour to a significantly slower pace. This near-windless region marks the transition into the turbulent interstellar medium. Our spacecraft shudders as we cross this threshold, entering a realm of cosmic storms. Looking back, we see our solar system encased in a protective shell of photons and particles. Further out, we encounter the Oort cloud, a vast reservoir of icy bodies, remnants from the solar system's formation. Millions of asteroids and comets drift within this ethereal sphere. Our guide announces that we're about to exceed the speed of light. Now we're free falling through the immensity of space on a journey towards the universe's edge. A brief presentation illuminates the universe's scale. Our astronomy professor explains that millions of galaxies are known to exist. Our Milky Way, the Magellanic Clouds, Andromeda, and countless others form the local galaxy cluster. This cluster, in turn, is part of a larger structure, the Gosper cluster. The journey continues, revealing the breathtaking scale and complexity of the cosmos. The vastness is almost incomprehensible, a testament to the universe's boundless expanse. Our understanding of this vastness is constantly evolving, pushing the boundaries of our knowledge further and further into the unknown. The journey to the edge of the universe is a journey into the very heart of discovery. In the vast expanse of space, phenomena of unimaginable scale exist. challenging our understanding of the universe. Today, we delve into the largest structures ever discovered, structures so immense they redefine our perception of cosmic boundaries. First, we encounter the Sloan Great Wall, a colossal structure spanning an astonishing 1.38 billion light-years in diameter. While vast, it possesses a distinct boundary, a defining characteristic that sets it apart. But even the Sloan Great Wall pales in comparison to the Hercules Corona Borealis Great Wall, a behemoth measuring a staggering 10 billion light-years across. These structures dwarf even the most spectacular events we observe: galaxy collisions, supernova explosions, and the brilliant flares of quasars. Imagine this: before you, the Great Wall, seemingly the edge of our known universe. A faintly glowing bulge stretches across your vision. Its boundary appears almost transparent, easily passable, but appearances deceive. Our astronomy professor explains that matter cannot penetrate this wall. The region surrounding the wall is subject to extreme distortions of space and time. We must maintain a safe distance. Numerous theories attempt to explain what lies beyond. The existence of the wall itself strongly suggests that our universe is not unique. If it were, a barrier of this magnitude would be unnecessary. The wall serves as both a protector and a boundary, shielding us from a realm governed by physical laws vastly different from our own. Beyond this cosmic barrier, a universe might exist where time runs backward, or matter exists solely in two dimensions. Travel to these other universes is currently impossible. Our physical bodies are inextricably linked to the laws of our universe, rendering such journeys fatal. Yet, some researchers believe they've received messages from beings inhabiting other dimensions. These messages, they claim, suggest life forms composed not of matter, but of pure consciousness. Our scientists believe that one day we too may traverse these dimensional boundaries, but as spiritual entities, unburdened by the limitations of our physical forms. Further evidence for the existence of other universes comes from supervoids, vast regions in the cosmic web where striking features hint at collisions with other universes. These areas act as cosmic scar tissue, remnants of interuniversal interactions. The Idona supervoid, a region spanning approximately 1 billion light-years and remarkably devoid of galaxies, is a prime example. In 2004, a research team investigated these supervoids, focusing on the thin cosmic filaments resembling scar tissue. Through meticulous calculations, they confirmed their initial hypothesis. These filaments are indeed the remnants of collisions with other universes, providing compelling evidence for the existence of a multiverse. The sheer scale of these structures and the implications of their existence continue to reshape our understanding of the cosmos, pushing the boundaries of our knowledge and inspiring further exploration into the mysteries of the universe. Evidence is mounting. Two universes colliding here. Not a cataclysmic explosion, but a more subtle interaction. Imagine two galaxies merging, a slow, gravitational dance of destruction and creation, but on a scale unimaginably larger. This wasn't a head-on collision, more of a glancing blow, a cosmic brush that left its mark. The universe is damaged, yet somehow altered. The very idea challenges our understanding of reality. Universes merging? It seems impossible. A violation of everything we thought we knew, yet the evidence suggests otherwise. Quantum researchers are exploring a fascinating hypothesis: invisible dimensions, existing alongside our own, functioning as universes in their own right. Think of it, not just universes nested within universes like Russian dolls, but a complex, interwoven tapestry of dimensions, connected, interacting, perhaps even influencing each other. The journey to understanding this cosmic tapestry begins beyond the wall. A great plasma wall, a boundary surrounding our universe, a barrier no one has yet crossed. What lies beyond? Vast voids, perhaps. Empty space stretching endlessly. But the sheer scale of this event suggests something more. A structure far grander than our universe alone. Our universe, our solar system, our galaxy, they are but tiny components within a larger, more intricate design. We are but one universe among many, and those universes, in turn, may be part of something even larger. Structures beyond our comprehension, dimensions we can barely imagine. Consider this: the entire cosmic structure we know, everything from the smallest quark to the largest galaxy cluster, might be contained within something as seemingly insignificant as a grain of sand. A single grain of sand on a vast cosmic beach. And if our universe is contained within something larger, what about the beings who might inhabit those larger structures? Are they observing us, watching the dance of electrons and protons in our atoms, just as we meticulously study the movements of celestial bodies? The thought is staggering, but the question remains, is there a boundary even within the subatomic realm? A limit to what we can perceive, a wall within a wall, hinting at further layers of reality beyond our current understanding? The search for answers continues. The universe, a boundless expanse of stars and galaxies, operates under a set of seemingly immutable laws. Yet, at the very heart of matter, at the quantum level, these laws begin to blur, to fray at the edges. We find ourselves confronting a fundamental limit, a boundary where our understanding falters. This isn't a failure of our instruments, though our current technology certainly struggles to penetrate this veil. It's a fundamental limit imposed by the universe itself. We're talking about the Heisenberg uncertainty principle, a cornerstone of quantum mechanics. It dictates that we cannot simultaneously know both the position and momentum of a particle with perfect accuracy. The more precisely we determine one, the less precisely we know the other. As we approach the limits of measurement, the very act of observation seems to disrupt the system, pushing the particle from a defined, measurable state into something far more elusive. This isn't merely a state of ignorance, it's a transition. The particle, once a discrete entity, dissolves into a probabilistic wave function, a cloud of possibilities. This isn't the end, however, but rather a beginning. This transition from particle to wave isn't a cessation of existence, but a transformation into a state of almost limitless potential. Think of it as a seed, containing within it the blueprint for countless possibilities, waiting for the right conditions to germinate. This boundary, this threshold where the particle state gives way to the wave state, might represent something far more profound than a simple limitation in our understanding. It could be a gateway, a portal to another dimension, another universe entirely. Beyond this boundary, physicists theorize, lies a realm of negative matter, a mirror image of our own, still largely unexplored and shrouded in mystery. Imagine, if you will, a reflection, a parallel world where the laws of physics are subtly different, slightly altered or expanded upon our own. Perhaps gravity works in reverse, or time flows in a different direction. Perhaps the very constants that govern our universe take on entirely new values. The possibilities are staggering, limited only by the bounds of our imagination. This exploration into the quantum realm, into the very fabric of reality, is far from over. The boundary between the known and the unknown remains a tantalizing frontier, beckoning us to push the limits of our understanding. We stand at the precipice of discovery, poised to unravel the secrets hidden within the quantum foam. Our journey here ends, but the exploration continues. The quest to understand the universe and its potential is far from over. Subscribe to our channel to join us on this incredible journey of discovery.